Good day, everyone. You're welcome back to my YouTube channel. So today, our discussion will be centered on identification and naming of some common functional groups. So today we'll be identifying and naming some common functional groups in organic chemistry. So that's what we'll be doing. I'll be giving the general formula and the principles for naming them. So let's start with the carboxylic acids. So the carboxylic acid, they have the general formula RCOOH. Are you getting it? So, for example, let's name a compound. Let's name pentanoic acid. Pentanoic acid. So, when you want to name it, don't forget the R part. So, to name a pentanoic acid, the R part will be butyl, and followed by COOH. So, now let's go. We have CH3, CH2, CH2, CH2. So, 1, 2, 3, 4. These are our butyl. Then COOH, CO, then followed by OH. So these are, so when we come together, our pentanoic acid 1, 2, 3, 4, 5. You can see that it's having 5 carbon. So that's for pentanoic acid. So now let's get to amine. So amine have the formula RNH2, the general formula RNH2. So that's an alkyl is here followed by NH2. So let's quickly write the structure of propar. Let's write for butanamide. Okay, let's write for butanamide. So if we have to write for butanamide, that means we need butyl and NH2 butanamide. So we need butyl. Now butyl is this CH3 CH2 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 NH2. So now this is it. 1, 2, 3, 4. Okay, I've drawn this propanamide now. CH3 CH2 CH2. 1, 2, 3, 4. CH2. Okay, this butyl NH2. 1, 2, 3, 4. So this butanamide. Can you see butanamide? That's the R part. So now we've done that. Let me quickly show you something. There's a situation where the N has been substituted. So let's see here now. CH3 CH2 CH2 CH2, then NH. Let's see, there's a methyl A. Are you getting it? Now, this will be N methyl 1, 2, 3, 4, N methyl butanamide, not amide, butanamide. Now let's move to this. So this one. So in a situation where we have another, the HA has been removed also, we have CH3 replacing it totally. Are you getting it? In this case here, it will be NN. Are you getting it? NN. Then dimethyl. Can you see the new formula will be NN to show that there is 2 times that the methyl appear. Then dimethyl butanamide. So that's. So let's talk about the amide also. They have the formula RCONH2. Are you getting it? They have the formula RCONH2. So let me write for propanamide. Is it propanamide I was trying to say? Propanamide. Okay, let me write for propanamide. So let me write for propanamide. So RCONH2. So in propanamide, we must not have more than, so prop means 3. Must not have more than 3 carbon. Now, let's go. That's CH3 CH2 CO NH2. Can you see? CH3 CH2 CO NH2. So these are our R parts, and these are CO NH2 parts. So this propanamide. Sorry, excuse me. I want you to know the difference between amine and amide. So this RNA2, this amine. Now RCONH2, this amide. So this amide. So take note. So also we can have the same situation in our amide. The same situation we have in amine, that we can have primary, tertiary amine. We can have it in amide also. So let's go. Now let's quickly talk about the ether. We have the general formula, the ether. Ether. They are called ether. They have the general formula ROR. The ether of the general formula ROR. So we have to draw them. Let's talk a situation. If I tell you to draw methoxy. So now let me quickly. There's something I've not told you yet. The ether are made up of this. Look at here. This place you have is the alkoxy part. Alkoxyl part. Why this the alkyl part? Are you following? Alkoxy part, alkyl part. So now I will illustrate that with a. So let's talk of drawing ethoxypropane. Now if you want to draw ethoxypropane, this is what will happen. Ethoxyl, in the sense that we are talking of earth. We are talking of earth, we are talking of two carbon. So ethoxyl, so we are talking of ethyl. Now this is the ethoxyl. Ethoxyl is OR, as I told you earlier, in the general name, in the general formula of the name. So now ethoxyl is OR. So which means you have an O and you have an alkyl also. So the compound I'm talking about, we are talking of ethoxypropane. Am I right? Ethoxypropane. Now let's go. So this ethoxypropane, let's write O, then let's write ethyl. That will be C2H5. Am I right? That's CH3CH2 ethoxyl. Now now let's talk of propane, ethoxypropane. Now don't forget, in the general formula of the name, that's ROR. This is an alkyl to ethoxypropane, which means we will put propyl here. Are you getting it? So now we will put propyl here. Propane is C3H8. Am I right? So propyl will be C3H7. C3H7. So normally, so it's telling us that the hydrogen that is supposed to be complete here, this alkoxy part has replaced it. Are you getting it? It's as if this is a part on its own that removed the hydrogen from here. So now the structure we have here is ethoxypropane. This is ethoxypropane. So if you have to draw it in a normal in a condensed form, it will be CH3 CH2 CH2. So O CH3 CH2 CH3. I want you to take notes. So in the naming of the ethers, you name the alkoxy part first, followed by the alkyl part. Are you getting it? So the alkyl part, you name it as an alkane. So that's it. That's that on that. Now let's move to the next one and identify the functional group. So let's talk about the esters. So esters have the general formula RCOOR. RCOOR. So they are divided into two. This is the first part here. This is the alkanoate part. Alkanoate. While this is the alkyl part. Alkyl part. So parts. Are you getting it? So this is the alkanoate part. This is the alkyl part. Now let's go. use when you are naming the esters, so just like the ether, you name their key part first. Are you getting it? You name their key part first, then you now name the alkanoate part. The alkanoate part follows. So let's go. I will illustrate it. So let's say we want to draw the structure of propyl propanoate. Propyl propanoate. Now propyl propanoate, want to draw the structure of propyl propanoate. So this propyl. Don't forget in the structure RCOOR. Are you getting it? So propyl. So which means is this that will come second. Now the propanoate is like propane. So now let's start with our propanoate. So propyl propanoate will come first in the writing of the name, then propyl will follow. Are you getting it? Now let's write propyl propanoate. Let's write the propanoate. The propanoate is it's made up of the R and the COO part. So our R here is propyl. So let's write down CH3, CH2, CH2, 1, 2, 3, yes. Then this is our R here. This is our R here we've written it. Then COO, then CO. Let's write it normal. So this CO, so CO double bond, COO, CO, then O. So we are writing propyl propanoate. So this is another propyl propanoate. So that will be CH2, CH2, CH3. So this is structure of propyl propanoate. Are you getting it? So propyl here, propanoate. So that one gone and settled. Which other one would I have loved us to identify again? Yes. Let's talk of the nitrites. Nitrites. So this is their structure RCN. Can you see? This is the general structure of the nitrites RCN, and our key is here, the carbon is here, and N, and the nitrite part. Now this is the nitrite part here also. Look at the triple bond. So that's how to identify nitrite. This is the main nitrile functional group there. Now let's go. If I tell you to write the structure of butane nitrite, let me write it. Butane nitrite. Are you getting it? So butane nitrite, if I say write the structure of butane nitrite, all you need is you need a propyl, join it with the CN part, then you have butane nitrite already. Let's go. So you must not. So this boot is telling you that you must not have more than 4 carbons there. Are you getting it? Now let's go. Butane nitrite. I want to write the structure of butane nitrite. This is what you do. That's CH3, CH2, CH2, then 1, 2, 3, then CN. Are you getting it? So this is butane nitrite. How? So when you count your carbon, 1, 2, 3, 4, you have 4 carbon, butane nitrite. So if you want to draw it, you want to grab it, this is the general structure, this is the R part, and this is the CN part. And you see, that's RCN. So you should know that when you are drawing propane nitrite, that means you will need a butyl. When you're doing pentane nitrite, you will need a butyl here. Are you getting it? In the case of butane nitrite, you need a propyl, because are you getting it? You need a propyl. So then when you come together with the carbon from the nitrite group, it will give you what you want. So take note of that structure. If there any other thing I would like us to know. Okay, let's talk about the aldehydes. and the ketones before we the aldehydes and the ketone. So the aldehydes, so they have the formula RCHO. Can you see they have the formula RCHO? So now let's write the structure. Let's draw the structure of pentana. So pentana will be CH3, CH2, CH2, 1, 2, 3, CH2, are you getting it? Then CO, then H. Now look, this RCHO, this is our R part. Are you getting it? Then this is the CHO part. 1, 2, 3, 4. So I talk of pentana, we are doing pentana. Are you getting it? Which means we need the butyl followed by the. So don't forget, you must know when you have pents, you must not have more than 5 carbons here. Are you getting it? And when you are counting the carbon, then the carbon carrying the carbonic carrying the carbonic group must also be counted. Are you getting it? So this is the structure of pentana. Now aldehydes. Let's talk of ketones too. Ketones have the general formula RCOCH3. Am I right? Okay, RCOR. So let me clean for. So these are the ketones. So now we want to draw the structure of ketones. That will be let's draw the structure of pentanone. Pentanone. So that will be. So let's the same way we draw the structure, just like the hydrogen aldehyde will be replaced with CH3. So that will be CH3, CH2, CH2, 1, 2, 3, CH2, 1, 2, 3, 4, then CO, CH3. Are you getting it? So this is the structure of propanone. Yes, this is the structure of propanone. So that's all for today. Thank you. So just follow the principles and be able to identify the functional groups. So subscribe to my YouTube channel. Thank you and God bless.